Hey guys, I want to finish yesterday's lesson on right triangle definition of trigonometric functions. So yesterday we learned this whole uh, idea of SOHCAHTOA. That was really helpful. Maybe we need to put that up here somewhere so we can have it handy today. Maybe it won't be in the way right there. And I want to take this idea of SOHCAHTOA a little bit further that we'll need for trigonometry and pre-calc B this semester. Okay, so let's do some more geometry review. I always ask my geometry teachers to cover special right triangles. These are the triangles that your teachers should have labeled 45, 45, 90. And 30, 60, 90. And the way that the two sides related to each other, don't remember which way she said she did this last year, but the way that sides relate to each other is that the shortest side is always going to be x. All right. Now on a 45, 45, 90 triangle, of course, two sides are going to be the shortest, so I'm going to call them x. And using Pythagorean theorem, I can find that the length of the hypotenuse now would be x times the square root of 2. So what does that mean for us? What do we need to know today? And hopefully what you did in geometry last year, that in order to go from the short side of a right triangle to the hypotenuse, I simply need to multiply by the square root of 2. However, if I'm coming back down the other way to go from the leg of a 45, 45, 90, I'm sorry, from the hypotenuse to a leg, I'm actually going to divide by the square root of 2. I got some examples on the next slide we can look at. Excuse me. Okay, so on a 30, 60, 90 triangle, we only have one side that is the shortest. And in order to go from the short leg to the hypotenuse on this one, I actually just need to multiply it by 2. It's going to be twice as long. Whereas if I'm just going from the short leg over to the long leg, I need to multiply it by the square root of 3. So I'm going to leave that up there for just a second while I show you the first example as to how we're going to expand this idea of what we did in geometry last year. So it says I want to find all the exact values or all the exact, is that even written right? Find all exact values of all the trigonometric functions of 30 degrees. Yeah, that works. So finding them all of 30 degrees. So what that means is I want to find sine of 30 degrees. I want to find cosine of 30 degrees. I want to find tangent of 30 degrees. I want to come over and do cosecant of 30 degrees, secant of 30 degrees, and cotangent degrees. So I'm going to go back a slide so I can see my triangles to make sense of this. And so if I look down here, what I want to do is I want to find 30 degrees in my special right triangles. That's right here. Here's 30 degrees. So all I'm doing is, from yesterday we used that Greek letter theta. Today I just want to use 30 degrees, this 30-degree angle, whenever I do all of my SOHCAHTOA. For instance, if you remember sine yesterday, it was opposite over hypotenuse. What I want to do is I want to look and see what's opposite 30 degrees. Well, that's going to be x. And I want to look and see what the hypotenuse of this triangle is. Well, that's 2x. Everything has an x, so a lot of x's are going to cancel today, and it would just leave me with 1/2. Okay, moving on, remember cosine was going to be the adjacent over the hypotenuse. So the adjacent side to this 30 degrees is x times the square root of 3. Hypotenuse is still the good 2x right there. And again, you're going to get a lot of x's to cancel. The x's were a little bit redundant on this, but I do believe this is how it was taught last year. And then we have tangent is going to be opposite over adjacent. Well, the opposite side is x. The adjacent side is still x squared root of 3. So I'm left with 1 over square root of 3 after those x's cancel. And it'd be nice not to have that square root of 3 on bottom. So I'm going to rationalize it, and I get the square root of 3 over 3 for that value. We're halfway there. Now, you're more than welcome to go back and look at your notes on this. Remember, when we started doing cosecant, secant, cotangent yesterday, those were new. And cotangent, remember, was going to be hypotenuse over opposite. I always write my 6 trig functions a certain way, though, because over here, for sine, I just did opposite over hypotenuse and got 1/2. So if cosecant is simply hypotenuse over opposite, I just need to take this 1/2 and turn it upside down, and I get 2. It's the same way with all of these. We discussed yesterday that secant was going to be hypotenuse over adjacent. Well, cosine, I just did adjacent over hypotenuse, so I just need to take that square root of 3 over 2 and turn it upside down. Unfortunately, on this one, that's going to require me to do a little bit of rationalizing, but not too bad still. And again, I can just take this tangent that was opposite over adjacent, and then cotangent, where it's just turned upside down, adjacent over opposite. So let's just take our final answer and flip it. I'll show you a shortcut. Well, those cancel, and there's left the square root of 3. Well, what does that mean? It means I was better off just flipping this upside down and getting my final answer. Okay. All right. Well, while I give you one to try on this, you can kind of check yourself with it. So let's do this 45-degree angle. We're kind of done with all that, so I'm going to erase it. So I'm going to give you one to do here. Let's change this 30 to a 45. Pause the video, and you can go back and look at your triangle. And what we're wanting to do is we're wanting to do sine, cosine, tangent of 45. And then the cosecant, secant, and cotangent of 45. Okay, so hit pause on the video. I'm going to work it out while you do, and then we'll see if we get the same answer. Okay, so this is what I got. Got some redundancy in there since we're dealing with, since you're, doesn't matter which 45-degree angle you pick, but since your opposite leg and your adjacent leg are the same, turned out to get a lot of the same answers on this. Okay, so play with that some in your homework. That's going to allow us to work these problems as well. Now, there's a couple of ways that we can work this one. Okay. If I'm looking at this triangle on the left right here, I see that I have a 30-degree angle and a 90-degree angle. Well, since there's 180 degrees in a triangle, the only angle this can be is 60 degrees. That's all I have left. So I get the 30, 60, 90 triangle. And if you look, they told me that the hypotenuse is 16. Well, I always like to find my shortest leg first. Okay. And if you remember, at the beginning of this video, we said that in order to go from the hypotenuse to the shortest leg, I just needed to divide it by 2. All right, because the hypotenuse will always be twice as long as the shortest leg. Once I get my hands on the shortest leg, I can then definitely check myself, make sure I double this and get the hypotenuse. But remember to come down to the longer leg, I just multiply it by the square root of 3. And I get 8 times the square root of 3. No labels, no angles are labeled on this triangle on the right. But if both of those legs are going to be congruent, that means both of these angles have to be congruent. And if both these angles are congruent, they both have to be 45 in order to make it so all my angles add up to 180 degrees. So if I'm just looking for the missing side length. So I'm looking for both of these sides. I'll throw another X up there. Remember, this one's going to be kind of weird. I'm going to try to find these legs right here. I remember that in order to go from here to here, I'm multiplying by the square root of 2. So I need to divide by the square root of 2 if I'm coming backwards. And I'm going to do just that. So that means this side length right here is going to be 16 divided by the square root of 2. And I can rationalize that. So I get 16 square root of 2 over 2. Well, that just gives me 8 square root of 2. And that's going to be the side length on both of these. Now, if this is kind of foreign to you, you're like, I really don't have any idea what's going on. You can still do a quadratic formula on this one on the right. You can do both a squared plus b squared, which is the same, is going to equal c squared. And if you work this out all the way down, you should still get the same answer that we got. So that's another way to check yourself, or if you're just drawing a blank on the quiz. But what if my angles are not 30, 60, 90? If they're not 30, 60, 90, and I'm looking for the missing side lengths, so here I'm looking for A and B, and we'll just go ahead and label these over here as well. We're going to look for A, and we're going to look for B. I'm going to have to bring this SOHCAHTOA back out and use it. So what I want to do is I want to look at the angle they gave me. They gave me 36 degrees. And what I want to do is, and if I'm looking at this, I'm told also what the hypotenuse is. So I want to come up here to my SOHCAHTOA and I want to find something that has hypotenuse in it. Well, there's two of them that deal with the hypotenuse. I have a hypotenuse here and here on sine and cosine. It doesn't matter which one I pick, I'm going to get the same answer. I'm just going to pick sine. So if I take sine of that 36-degree angle, it tells me that sine is going to be the opposite over the hypotenuse. So the opposite side here is A, and the hypotenuse in this one is 10. So I just have a little bit of algebra to do on this. I want to solve this for A, so I just multiply both sides by 10, and that will solve it for me. Here the 10s cancel. And sine of 36, I really don't even know what that is. Okay, so I'm going to pull out my calculator. Got a little treat for you guys on this one. So I'm going to pull out my calculator. And I'm just going to do, clear it. And I'm going to do sine of 36. Gives me this really weird decimal. And then multiply it by 10. And that tells me the length of side A. So side A is going to be 5.88. So that's how long this is. 5.88. I have one more side length to find. It's going to be this side length down here, B. And let's see, to find side length B, I could come over and start using cosine on this. I could do this time cosine of 36 degrees equals the adjacent side B over 10. Solve this for B. Or I could just do Pythagorean theorem on it. That would work as well. So whichever way you feel most comfortable with. So on this one, I would multiply by 10. I'll just go ahead and do it this way since I've already worked it out some. So I've got clear here. Oops. Clear. I got 36. That's 336. Let's just do 36. Then I hit my cosine button. And that's going to be that weird ratio that is adjacent and the hypotenuse of a 36-degree angle in a triangle. And then again, I'm just going to multiply it by 10. 8.09 for this link. 8.09 down here. So I've given my missing side links right here using SOHCAHTOA. And like I said, if I would have set this up and did 5.88 plus my b squared is equal to 10 squared and solve this all the way down for b, I still would have got the same answer for this one. Okay, so which is whichever way you feel more comfortable with. I'm going to let you work B over here. I'm going to go back to present mode here. I'm going to let you work this triangle right here on the right. Keep in mind what sides you have and what you're looking for. And then I'll work the problem as well, and we'll see if we match up. So go ahead and hit pause. All right, I once again didn't use Pythagorean theorem on this one. I went ahead and just used like tangent and sine this time. And so use my little move the hat trick on there, or took the reciprocal of both sides and then multiplied. So hope you got that. If not, ask questions about it, post something in the comments if I did something wrong there. All right, so these sprinkle into word problems that I'm going to be assigning. And so two definitions that you need to know are angle of elevation and angle of depression. So angle of elevation and angle of depression, big thing that people miss a lot is that it's always made with the horizontal. Right? There's going to be a horizontal line that's either usually a person's line of sight, or the angle of depression, angle of elevation could be made with the ground, like we'll see here in just a little bit. Whenever I'm talking about angle of elevation, what I'm looking at is I'm looking like this guy's looking up at an airplane. He's looking at something that is above his line sight, his sight line right there. So he's looking up at the airplane, and that's causing this angle to go in a positive direction and move upwards. However, if he's looking at this fierce dog down here, he's looking down. We call that an angle of depression since it's looking down. You should see some of both on some examples. So here we have the Jolly Green Giant. If you don't know who the Jolly Green Giant is, you might not be eating enough vegetables. But in order to measure the height of this Jolly Green Giant, I'm standing 25 feet away from the base of the giant. Okay, so we're just going to call this 25 feet from here. I'm going to bring it over here so I have room. So this distance right here is 25 feet. Here's Mr. Lowlady right here, a bald head, big teeth, put some big teeth in there. It's just a dot. But and then I'm measuring the angle of elevation from the ground this time, so not from my eyes, but from the ground to the top of the Jolly Green Giant's head to be 55 degrees. Oh, it's one of those weird angles again. So to the top of his head right here, boom. This angle right here with the horizontal, that's key, with the horizontal is going to be 55 degrees. What I want to know is I just want to know how tall the Jolly Green Giant is. I'm running out of colors here. I better not use green so I'll be able to see it. So I just want to know X right here. How tall is the Jolly Green Giant? Do you guys see the triangle in it? So think about it. Which one of my trig functions do I need to use if I'm looking for the side that is opposite this 55 degrees, but I'm given the leg that's adjacent to it. So I'm dealing with opposite and adjacent. Should be my tangent, right? So I've got tangent of this 55-degree angle is going to be the opposite side, which is x, divided by the adjacent side, how far away I am from the Jolly Green Giant, which is 25 feet. Again, I just want to solve this for x. I see that I'm dividing by 25. The opposite of dividing by 25 is multiplying by 25, and that's going to solve it for x right here. Gotta get my handy dandy calculator. Hold on. Calculator. Is that the right one? Yeah. Okay. So clear it out. I'm going to do tangent of 55. Tangent. So that gave me kind of a bigger number. And then multiply that by 25. 35.7. So the Jolly Green Giant is going to be 35.7 feet tall. Pretty good giant right there. One thing I do want to point out is if your calculator answers are not matching up to what I got in this lecture, you really need to make sure it says degree right here. Okay. If it doesn't say degrees on your calculator screen, it might say radians instead. And so what you need to do is you need to hit mode and make sure it says degrees for now. Okay. That's it, guys. That's all I got. So here's some practice problems. Make sure they match up with what's on Google Classroom. And again, it's just more SOHCAHTOA. We're just dealing with some angles and get to play with the calculator a little bit. If you guys have any questions, make sure you post them, have them ready in class, and I'll see you guys next time.